Professor Bob Young here, and in this instructional video we are going to discuss what's called function or functional notation. And when a function f is defined with a rule or an equation using x and y for the independent and dependent variables, we say that y is a function of x to emphasize that y depends on x. So we use the notation y equals f of x, called function notation, to express this, and read f of x is that little notation there, f of x. The letter f is the name given to this function, so this is function named f. It could represent flowers or any other thing, any other word that begins with f. So, for example, if y equals 9x minus 5, in functional notation, we just replace y with f of x, and we rewrite this as f of x equals 9x minus 5. Note that f of x is just another name for the dependent variable y. So, for example, if y equals f of x equals 9x minus 5 and x equals 2, then we find y or f of 2 by replacing x with 2. And this is called evaluating functions. So notice if we plug 2 in wherever we see an x, and that's what they did there, that the 9x minus 5 becomes 9 times 2 minus 5 and gives us 13. So the statement of x equals 2, the y equals 13 represents the ordered pair 2, 13, and in functional notation it looks like this, f of 2 equals 13. So this is just a fancy way to write an ordered pair, saying when x is this value, y is this value. Now notice how this is read again, f of 2 or f at 2, but most of the books I've seen is always f of 2. All right, so let's play the evaluate functions game some more. So we'll go ahead and plug some other numbers in this function. F of x equals 9x minus 5. Starting with, in pretty blue here, we'll put in 0 for x. So f of 0 would be 9 times 0 minus 5 would equal negative 5. F of negative 3 would be 9 times negative 3 minus 5 would give you negative 27 minus 5 or negative 32. So, you know, some people look at a function and they say if you put things in, that's the old input output we talked about when we were defining functions in previous videos and so forth. You put something in for x, you'll get something out for y. So down here on the bottom here, notice they've got the name of the function f, the independent variable plugging things in for x, and y or f of x depends on what we plug in for x. So variations of the definition of function. So let's run through this again real quick. We've talked about this before, but just to make sure you got it, a function is a relation in which for each distinct, remember, or different value of the first component or x of the ordered pairs, there's exactly one value of the second component or y. A function is a set of ordered pairs in which no first component is repeated. X's can't cheat. And the function is a rule of correspondence that assigns exactly one range value to each distinctive domain value. Now, again, be careful. I've seen a lot of students new to college algebra and so forth. This symbol f of x does not mean f times x. So be careful there, but represents the y value for the indicated x value. As just shown, f of 2 is the y value that corresponds to the value of x when you plug 2 in there for x. So, you know, just watch out for this new notation here if you've never seen it before. So again, we're going to go ahead, and they gave us some new functions to play with here. Look, they gave us the f of x function is negative x squared plus 5x minus 3, and they defined a function g of x here, which is 2x plus 3. It says find and simplify. So here we're going to go ahead and find the value of f evaluated when x is 2. So wherever we see an X, we're going to plug 2 in here. Now, one thing I don't like about what they've done in this graphic, when I tell my students something here, notice that when you have f of x, there's parentheses around the x, correct? So when you evaluate functions, what I want you to do is make sure you lock in all of those x's, just like I did. So put a parentheses around every x when you substitute in, and that will save you the pain of sign errors. Because notice down here, when I plug 2 in wherever I see an x, I've got negative 2 squared, and that negative is outside the parentheses. See, so a lot of people, if you took that wrong, if you said, well, if I just put negative 2 in there and squared, I get a positive 4, if you lock in your x's, you'll never make that mistake when you evaluate functions. I can't even get calculus students to do that come see me. So be careful. Whenever you're evaluating functions, look up here at g of x, I'm going to do. I'm going to lock that one in too. Lock in your variables to prevent disaster. And we get the answer of 3. So notice f of 2 equals 3. Huge point there. And the ordered pair 2, 3 belongs. If we were to make this graph and plot it, that point would be on the graph. So we're staying with some functions up top here. And now they're saying find f evaluated at q. So not only can you put numbers in for x and get y values out, you can plug anything in for x. You can say f of q here. So all we're doing is wherever we see an x, we're putting in q. And we're getting negative q squared plus 5q minus 3. I had an old high school coach that would say you could put anything in here. You could put your mama in here for x. I'm going to say f of your mama. That's bad, isn't it? And all that would be is minus your mama squared plus 5 times your mama minus 3. And people be going, hey, don't talk about my mama, coach. We'd get on our coach. But that was going back to the old football days when Young was a much younger man. You know, I've had other instructors say you could put kitchen sink in for x. You could say f of kitchen sink would be minus kitchen sink squared plus 5 times kitchen sink minus 3. So you can have fun evaluating functions. All right, now we're going to pick on the g function over here. We've been picking on f a lot, so let's go ahead where we see the g function here. And again, I'm locking in the variables here. And they finally did it down here. When you plug in a plus 1, wherever you see an x, see, I think locking that in really helps. Then you're just going to get 2 times a plus 1 multiplied there plus 3. So notice to get the answer here, we're going to distribute. Get 2a plus 2 plus 3, and collecting like terms here, we'll put the old CLT. We will get an answer of 2a plus 5. So notice if I plug numbers in for x, I get numbers out for y. If I plug letters in for x like q, we get values of q out for y. If you plug mama in for x, you're going to get y in terms of your mama. All right, so for each function, find f of 3 here. So again, we're just taking values for x, substituting it in. I hope y'all want some of these on the test because you'll definitely have 1 or 2 where you just have to take and evaluate functions. So again, here's an example. They're just plugging in 3 wherever they see an x. I wish they would have locked it in up here. I can't even get textbook publishers and whoever to do that, but it just makes it much nicer. So you'll get 9 minus 7, substituting 3 in for x there. And you will get f of 3 equals 2. And remember, this is just a fancy way of writing the ordered pair. When x is 3, y is 2 in this fancy functional notation. All right, now sometimes they'll give you a relation here, and they'll say find f of 3. So they'll give us a whole bunch of ordered pairs, and they'll say find f of 3. Now that's not really hard because if you know what 3 is in place of, and in this case, remember, functional notation is always f of x. 3 is really in place of x. So if you look at these ordered pairs here, I wonder what f of 3 will be. In other words, what's the y value going to be when x is 3? Yes, it's going to be 1 there. So they can play this game with you as well. They can give you relations and say, evaluate. They can also give you the block notation we talked about way back. Find f of 3 here, and notice again the domain or x value's 3 there. So down here 3 matches up with 5. So just a pictorial representation of evaluating functions. And they could even do it graphically. They gave us a pretty blue line here, and they said, find f of 3 on this line. So we're going to go over here, and I'm going to use some different colors here on this graphic. So I'm going to go over here to where x is 3. That's what we're looking at. Hey, we got f of x. X is 3 here. What is this y value up here is what they're after when x is 3. And notice y is going to be 4 when x is 3, and that's what they're after graphically. So they can have all kinds of fun evaluating functions. Okay, finding an expression for f of x, consider an equation involving x and y. Assume that y can be expressed as a function of x. To find an expression for f of x, 1, solve the equation for y and replace it with f of x. So notice here it says, assume that y is a function of x, and it is in this case, because if we were to graph this, we would say this graph would pass the vertical line test. All of the x values are different when we were to look at it. So notice here, if they just give us y equals x squared plus 1, you want functional notation? No biggie, just replace y with f of x. And then, if you want to evaluate the function here, it says find f of negative 2 and f of a, so just plugging in some values for x here. Now again, I don't like this fact that they did not lock in the variable here. Now notice when you do in this case, the negative 2, when you substitute it in down here, is all inside the parentheses, so when you square it, you get a positive 4 plus 1 to get 5. So again, notice the difference in the earlier example when the negative was outside and versus when you plug negative values in here, if you lock in your x values where it's inside. That's huge. And then if we do the same thing here, if we just go ahead and lock in this x value and we plug a in wherever we see an x, that's kind of an easy one there. We get f of a equals a squared plus 1. And if you wanted to write that ordered pair, it would look like this. It would be when x is a, in this function, y comes out a squared plus 1. I know y'all want to do f of your mama. Stop it now, y'all. It's going to be mama squared plus 1. Stop it. All right. Gosh, tell y'all are even bad on the videos. Now, here's one that's in a different form here. They don't have y by itself. So all we have to do here to get this in functional notation is solve for y. So we're going to go ahead here and show the steps, subtract x from both sides, and then divide everything by a negative 4 here. Now, I don't know why, but I'm not seeing a negative 4 down here on the bottom, are y'all? So there may be a mistake in this graphic. Oh my gracious. They dropped their sign. It happens to everybody, so don't feel bad if you do it here. Now, maybe they corrected it here. So it looks like they divided by a positive 4. So notice I think they're okay. The graphic is correct because they just did an extra step. I would have just divided by the negative 4 here and then went down here and say, well, a negative divided by a negative is positive 1/4 x minus 5/4. So rats, I didn't catch them on a mistake there. And there it is in functional notation, replacing y with f of x. And then just for fun, let's take and plug in negative 2 there for x and a for x. And you will see that, again, you'll come out with a couple different answers. So hopefully that you now understand functional notation and how to evaluate functions. Bob Young signing off.